Hello everyone, welcome to the third video for cumulative review number 13. We just ended with number 14 where we ended up rationalizing, meaning multiplying top and bottom by root 6. And the reason we did that is because if we decide to multiply top and bottom by root 6, we're multiplying by 1, so we're just changing what the problem looks like, not the meaning of the problem. And also, if you multiply a radical times itself, it generally always becomes a perfect square in the denominator. So the radicals disappear, which is the point of rationalizing, because we want the radicals to disappear out of the denominator. So with that said, looking at number 15, I noticed that I again have a radical in the denominator. So what we'd have to do is multiply by the problem, which is the square root of 5. And if we do so, what we can do in this example is, again, we can multiply straight across. And if we do so, we would get 4 root 15 in the numerator, because we're allowed to multiply two radicals, but the 4 would just stay in front. The denominator would become root 5 times root 5, which originally would be root 25, but that is really just 5. And so I have 4 root 15 in the numerator. In the denominator, I have 5. And last but not least, I'd look at to see if I can do anything with the root 15. I could split it into 5 and 3, but neither are perfect squares, so it doesn't really help me. So what I've done is removed the radical in the denominator, or rationalized it, so we are done with number 15. Number 16 still uses the idea of rationalizing. However, for the first time, we don't just have a radical in the denominator, we have a radical attached to the 8. So what we have to do here is the idea of the conjugate, which is the opposite sign in the middle, multiply top and bottom. So it looks something like this. Multiply the bottom by 8 plus root 2, and the top also by 8 plus root 2. This is a problem that does take a little bit of time, because in the numerator, I would have to distribute. So let me first rewrite the problem a little bit more neatly. I have 6 times 8 plus root 2 in the numerator, and in the denominator, I have 8 minus root 2, and I have 8 plus root 2. So in the numerator, I would have to distribute. So I would get 48 plus 6 root 2. I'm allowed to multiply these, but the 6 and root 2 view them as not like terms, so they have to stay separate. In the denominator, I have to FOIL or distribute. I prefer the word distribute. The first thing we would like to distribute is the 8 to both of these terms. So that would be 8 times 8, 64. 8 times root 2 is just 8 root 2. Part 2 is distributing the negative root 2. So negative root 2 times 8 is negative 8 root 2. Negative root 2 times positive root 2 is negative root 4. I am allowed to multiply and change the number underneath is because I have two radicals. And so if I keep simplifying, I notice that in the denominator, let me extend this page, I notice that in the denominator, the 8 root 2 minus 8 root 2 crosses out. So I have 48 plus 6 root 2 in the numerator, and the denominator I have 64 minus root 4 right now. Notice I'm not crossing anything out from top to bottom. I am simplifying the numerator completely and the denominator completely first before doing anything up and down. These two are not like terms, and you'll realize that soon because this one does not have a root 2. So I'm going to leave this as 48 plus 6 root 2, but my denominator really becomes 64 minus 2 because the square root of 4 is 2. So if I keep simplifying, I would get 48 plus 6 root 2 all over 62. Now, if again you think like the quadratic formula, the root 2 is not a like term, but these three are. So what can I take out of 48, 6, and 62? Well, I know I can at least take out a 2, kind of a common theme with these problems. So my answer simplified would be 24 plus 3 root 2 all over a lovely answer of 31. And I know that some of you might be looking at that saying, wow, this problem seemed a lot more simple at the beginning. Like this seems like a more simplified version than where we went. But trust me when I say in geometry and pre-calculus that you need to know this skill of conjugating because it'll help with things to come. And the whole goal, again, is to get the denominator to no longer have a radical. The reason this works is if you take a look up here, when you multiply by the conjugate, your middle terms will always cross out and you will always get a perfect square, so there is no longer any radicals in the denominator. All right, on to more cumulative review. If you look at number 17, the directions are just factor, not factor and solve. Just want to get the parentheses. So when I look at this, I first ask, is there a GCF? No. The next thing I look for is, do I have perfect squares on the ends? No. Do I have a lead number of 1? No. So if nothing else works, this is when we would split the middle. Sorry about my handwriting there. So we have to split the middle, and so the first thing we'd have to do on number 17 is multiply a times c. And if I did that, I would get negative 30, and then I would list all the pairs of numbers that multiply to be 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6, I think, is my options. And then I'd have to look to see which one or ones of these could combine or add to be the middle term. Now I notice that if I'm trying to get 13, I do have two options. I have either 3 and 10 or 2 and 15. However, I need a negative 30. So let's think about this. If I need a positive 13, both of these numbers would have to be positive. So there's really no way that two positives could ever be a negative when multiplied. However, if I want to get 15 and 2 to be 13, that would be 15 minus 2. And then negative 2 times positive 15 is negative 30. So this is my pair. And so I would take my middle term and split it into this pair. I would carry down the 10y squared. I would split this to be the 15 and the negative 2. It doesn't matter the order. I'll just go with the order that I see. So I will do negative 2y plus 15y minus 3. Bring that down also. So now I've created 4 terms, and whenever I want to factor with 4 terms, I end up grouping. And I think GCF. So I look at these first 2 terms. Notice that my greatest common factor is 2y. So when I take a 2y or divide out a 2y, I'm left with 5y, but then 2y divided by itself is just 1. So I'm left with 5y minus 1. In the second pairing here, 15y minus 3, I'm going to bring down that plus, and I can take a 3 out of both of these, and I'm left with, let's see, 15y divided by 3 is 5y, 3 divided by 3 is 1, so I'll be left with minus 1 again. Sorry about that cover up there. So it looks like both of my parentheses are the same, so one factor is the 5y minus 1, and the other factor is what I'm left with, which is 2y plus 3. And so this is my answer, and again, I did not solve because I do not see an equal sign in this problem. So I'm done here. Number 18, however, does say factor and solve, and because it is equal to 0, I eventually do want x equals a number. Now, if we look at our factoring list, let's always start at the beginning, shall we? If I look at this, do I have a GCF? I do. Let's start there. If I look at these 2 terms, I can take out a 4, and I can take out an x. And so if I took 4x out of both or divided it by both, 4 divided by 4 is 1. X squared divided by x is just x. So I took 1x out of 2. 20 divided by 4 is 5. If I take the x out of x, it's gone. So I'm left with this. Good news, I have no x squared. So I cannot factor anymore. So what I can do is just continue to solve. I can say that 4x equals 0 using the zero product property, and x minus 5 equals 0 using the zero product property. Over here I divide by 4, so one answer is x equals 0. In this equation I add 5, so another option would be x equals 5. And it makes sense that there's 2 answers because my original equation was x squared. Last 2. Number 19, simplify the following exponents. Please do not leave any negative exponents. So if I take a look at this problem, I notice that I'm raising to a negative exponent, and there are 1, 2, 3 bases inside there. And this is really 3 to the first. So this ends up being 3 to the, Whenever I have a power on the outside, I multiply the exponents. So 3 to the 1 times negative 3 power, a to the negative 4 times negative 3, and b to the 6 times negative 3. If I simplify that, that would be 3 to the negative 3rd, a to the positive 12th power, and b to the negative 18th power. That's a 6. So remember, I do not want any negative exponents. And so what I have to do is flip this and this to the denominator. So a to the 12th stays on the top, or in the numerator, and the denominator ends up being 3 to the 3rd, and then b to the 18th. And when it flips, the exponent changes from negative to positive. Now notice, this did not cause a negative number. It again caused it to flip or reciprocal. I can keep going a little bit, because 3 to the 3rd is not 9, guys. 3 to the 3rd is 3 times 3 times 3, or 27. So my final answer would be a to the 12th over 27, b to the 18th power. Last but not least from this semester, some review of just simplification of polynomials. The reason I picked 20 to end on is this is something that standardized tests love to put on their multiple choice tests because so many students fall for a trap. And I put it specifically after this exponent one also to show you the difference between the two. Pun intended, because difference is subtraction. No? Good pun? Sorry everyone, I had to. Number 19, notice that there is no plus or minus signs in here, so it's okay to raise everything to the negative 3rd as you see it. This problem though, we're doing 6x minus 7y squared, so because that subtraction is there, we need to write this problem out as 6x minus 7y times another 6x minus 7y. We unfortunately can't just do 6x squared and negative 7y squared because as you'll see, we'll be missing a good chunk of the problem. So this, like the beginning of this packet, we did FOIL or distributive property, and so that's what we have to do here. If I distribute the 6x to both, 6x times 6x is 36x squared. 6x times negative 7y is negative 42xy. If I look at distributing my negative 7y now to both, negative 7y times positive 6x is also negative 42xy. And yes, y times x is the same as x times y, so I just kept it alphabetical. And then negative 7y times negative 7y is a positive 49y squared. If I would like to simplify this, I notice that these two terms in the middle do not cross out, but they are like terms because they both have xy. So my final answer would be 36x squared. Negative 42 plus negative 42 is negative 84xy. Notice I did not change my exponents here because you're just adding the like terms. And then plus 49y squared. So this would be your answer multiplied out. All right, guys, that's the end of video 3. Feel free to go back and watch anything again if you need to. And as usual, I hope that these videos were helpful for you. All right, good luck studying.